All right, so today we are going to be talking about a smart contract for academic credentials. Sometimes when you're having to ask your university for credentials or you're at a new job and they need credentials from the university, it takes a little bit of time for that to happen. But with blockchain, we can make that process almost instantaneous without having to go through SQL. So the code I've written is pretty well commented, so I'll go through it quickly, and then I will talk about the architecture a little bit, go a little bit more in depth with that because this is the final, and then I'll do a little demonstration of about where the university would add a student to the blockchain. They would be verified. An employer would come and look to make sure that they're verified and see that. And then I will also do a scenario where a malicious actor comes in and tries to give themselves a degree just by, altering the contract. All right, here we go. So the code here, first we, define the contract. We got our state variables, address of the university, counter to give every issued credential a unique ID number, custom data structure right here. Then we have our mapping. Then we have the event credential issued. It allows external applications to listen. Modifiers. Rules which we attach to the functions, and then this one says that only the admin can have issue credentials. So this is the message that pops up if you try to add somebody without the proper credentials. We have our constructor that runs when the contract is first deployed to the network, and it sets the person deploying as the admin. All right, so core functions, we have issue credential. So we've got the incrementer here, new credential. We've got the ID, student name, degree name, issuer name, and then the timestamp. We then broadcast that. We then have verify credential function with our error checking here, checking to see that the credential actually exists. So we've got all this here. And it returns the student name, degree, issuer, and date here. Okay, so before I do the demo, just a little bit about the architecture here. So the issuer layer or the authority layer or trusted layer, whatever you want to call it, in this architecture would be the university. The university in this case is not necessarily defined by username and password, but it's actually defined by a specific cryptographic address. In this case, it's going to be this address right here. So the role of this layer or this authority is to write permissions. And then basically, so upon deployment, the smart contract captures the deployer's address and permanently sets it as the admin, which we talked about earlier. And for security, for this layer, every time a request is made to issue a degree, the contract checks the sender's digital signature, and then if the signature does not match, there's no credential issued. Nothing happens. All right. Then, of course, we have the logic layer, the smart contract. So instead, like I was mentioning before, instead of like an SQL database, in this case, we would use Solidity mapping that kind of acts as like a permanent lookup table where the unique ID points to a struct containing the student's data. Great thing about smart contracts is the immutability. Once the university pushes data to this layer, it becomes part of the blockchain's history and cannot be edited. So that, is one of the things where you got to be really careful, of course, not to accidentally put in false data, but the pros of being able to access that data quickly, and the fact that there are other security benefits for blockchain just inherently. The immutability is a good thing. Let's see. Then we have, so for the state management of this layer, the contract maintains a global counter to ensure that every degree issued has a unique sequential identifier that they can, and those identifiers cannot conflict with each other. All right. We then have the verification layer. We could call this the public interface. This is the final layer. It's a public access point, and it's designed for third parties to access. So unlike university portals that can require logins and fees, this layer is permissionless, so anybody can check this. It is read-only logic. So the verification function is a view function. So the public is allowed to read, but not allowed to change it for obvious reasons. And then the trust model here, the verifier does not need to trust the student's claims or wait for the university's office hours. They can just trust the cryptographic proof of the blockchain here. So basically, in summary of the data flow, the contract is deployed, university claims ownership, university sends a transaction containing student details, the contract locks this data into a credential struct and assigns it an ID, and then the verification. An employer inputs that ID into the contract retrieves the struct from the blockchain state and returns the authentic details instantly. So finally, let's do a little demo here, and then we will be finished. So we're just going to go through that process and see how it looks on the screen here. So right now, my account is the university. This will be the university account, and I'm going to give a student a degree. Well, log a student's degree that he or she earned. All right, so that is found through the issue credential. All right, so this student's name is, let's just call him or her, let's call it Mary Stein. That's her name. And she's getting a degree in botany from Northwestern. Cool. All right, so then we are going to transact this, and we can see that popped up here. Open this up. We will see the information. Mary Stein, botany, Northwestern. Now that is complete, we have Mary assigned to the blockchain here, block number 8 in this case. And then let's just go ahead, make sure that credential counting is correct. Yes. Okay, perfect. So this is going to be number 1. All right, so now let's say that I am a employer or a third party, and I want to see if Mary Stein actually has a degree in botany from Northwestern. So what we're going to do is we're going to verify the credentials. So in this case, the ID number would just be 1 in this case. And we're going to call that. And boom. Mary Stein, Botany, Northwestern pops up. And we can see all that information here and the timestamp as well. All right. So that is almost everything. The last thing I'm going to show you is, let's say that you are a hacker or a malicious actor of some sort, and you're trying to just get a degree, right? With a different, so you would be coming from a different account. So I'm gonna switch accounts here. So I go down to the little contract here, and I say I am going to give myself a degree. So we're gonna say sneaky hacker is getting a degree in sneakiness. I don't even know that's how you spell it. All right, from Hogwarts. All right. Or let's just say from, let's see, Northwestern. Let's keep the school the same. Let's say they're trying to, get in the Northwestern's smart contract. And I'm going to click transact. Uh-oh. Of course, access denied. Only the university can issue the credentials. All right. Yeah, so that is all I have right now. And that'll be all.